Hello again, folks. Here's just a quick reminder on how to create a scatter plot. For this lab, there are two scatter plots that you need to create. I'm going to show you how to do the mass versus volume graph, and then you're going to also have to do the density versus volume graph, but this one on your own. So you're going to have two graphs that are going to need to be imported into your density of liquids lab. So the first thing I would do is go to my density of liquids lab, and I would copy and paste in the data here for the mass of liquid A and the mass of liquid B. So we're just going to copy and paste that information right in. Okay, so assuming that this is the data you got, may not be, I'm not sure. We want to make sure we have the mass of liquid alone versus the volume of all of these here. So let's just make sure these are all to the proper place value here, tenths place. Okay. Once you have your data in here, it's really important to highlight what you want. So we're going to highlight from this volume over and then all the way down. So that's the entire data set that I want to have graphed. And I included these section headings up here so that they help me to label everything when I go and do my graphing. Once you have this properly highlighted, you can go over here to this little chart function, or you can go to insert and go all the way down to chart. Either way brings you to the same place, apparently. Can't tell if I'm having a lag here or not. Yes, here we go. Okay, so this is not the chart we want. We do not want a column chart. We want a scatter chart or a scatter plot. So we scroll down and there it is. Here we go. And you can see we have two different colored line dots there. That's good because here blue represents liquid A and red represents liquid B, and that's what we would like to see. So once you have the proper chart selected, we want to make sure to go over to Customize. And under Customize, we're going to start with our title. So the chart title doesn't really describe what this graph is showing us. So I might come here and type something in like something that makes sense. It helps to describe what this graph is looking at. So this would be how volume affects mass. Whoops, I forgot that E. So it helps if we spell correctly. I'm really not awesome at it either. So here we go. How volume affects mass. Could be one title you put in there. The title should just represent what it is we are looking at. It shouldn't be generic, and don't leave a title that typically pops up. Okay. Next thing is I'm going to go right to this drop down. I want to add a chart subtitle with your name. Right? This is something you should be familiar with. We've made plenty of these graphs this year towards the first half of the year, so it should all be slowly coming back to you now. So your name is in there. If I were to look at my graph right now, I can see that volume is on the x-axis, and that's what I want because this is my independent variable. And so my dependent variable should be along the y-axis, but you can see there's no label or unit. So we would come here to the vertical axis and type in what should be there. Now this is the mass versus volume graph, so I want to have mass and my unit, little g, for grams. See, now it has popped right up. I have labeled axes with units now that help represent what I'm looking at. So the charts axes titles are done. We're going to come down now to series. Series is going to help us differentiate or change what is going on with these different liquids, and also allow us to add the trend line. So let's do that first. So it applies them to all. Now each of my line has their very own trend line, and I leave it just like that, no big deal. However, I don't like that they're both point shapes are circles. So in order to change one but not the other, I have to come up under series where it says apply to all. I need to switch it and choose one. So I'm going to change my liquid A. Instead of a circle, I'm going to make it something completely different. So how about a triangle? So now it's really easy to see that there's a difference between these two because one is a circle, one is a triangle. And yes, they are red and blue. And because we can see the color, that is totally acceptable. I just always like to differentiate the shapes to change them up. All right, so now we go back up here and we go to apply to all series. So now let's check out our series. I see that they're two different shapes, they're two different colors, they have a trend line. But there's one other thing we need to do with the trend line. We like to see, do you remember what it's called? The R square value. Just shows us how closely related all of our data is. So at this point, we have a good title, your name, my X and Y axes are labeled with unit. I have a differentiation between a liquid A and liquid B in color and shape. I have my trend line, I have my R squared value. So we're done up to this point. There's only one other thing I can do to help add some detail to this particular graph, and that is to go to my grid lines. Now remember, with grid lines, I don't disrupt major grid lines. Those stay on auto, but I want to add, okay, and I'm adding this to my vertical axis. I want to add minor grid lines. So if my vertical axis goes from 10 to 20, what could I add to help make the space between them a little more descriptive? In this particular case, I would try to count by fives. So my 0 already exists, but I'd need a line for the 5, the 10, and the 15. So that would be adding 3 different lines here so that I could estimate a value somewhere in here that would tell me whatever this value is here would be happening at the 15 milliliter mark. Okay. And once I've done minor grid lines only, leave the majors on auto, minor grid lines only, I'm going to change this to my horizontal axis now and think of the same thing. I'm going from 10 to 20. How could I count from 10 to 20 to give detail? Okay, so in this particular case, I would count by twos. So I have my 10, but I would need a line for the 12, 14, 16, and 18 milliliter mark. So that is 4 minor grid line values. So minor grid lines, and I add 4 here. And now I have 10, 12, 14, 16, 18, and then 20. So it makes it nice. Okay, it's a great way to add some detail to your graph without making it too squished with lines. All right, well, there we have it. That right there is a really nice perfected scatter plot. So at this point, once your graph is as beautiful as you'd like it, I would click on it, hit Control C, come over to your document, and where it says graphs, I would do Control V, and you're going to link it to the spreadsheet. So if anything were to change there, it would easily change here. So here's the first of the 2 graphs you have to put in here. Make sure you hit enter a couple of times so that when you go to put your next graph in there, it doesn't squish up with the formatting. Okay, and there you have it, folks. I've done one graph with you, and you should be pasting this into your document. You now have to come back here, move this out of the way, and create the graph for the density versus volume. So I've got the data table here for you. I'm sharing this exact spreadsheet out with you and want you to make both of these graphs. This one on your own. This will be the graph that I actually grade because I've just shown you how to do the other one, and you should be able to apply all of those parts that we went over for the first graph to making the second graph also. Great. Good luck. If you have questions, please feel free to message me.